Down is towards the origin. Down is the origin, and you're integrating sectors, remember? So what was that formula? It was like the integral from what? Alpha to beta of what? What is it? Sam, team, what is it? You guys have been doing this question, so what's the formula? It's F what? Theta squared?
Theta and then squared, yeah. The whole thing is squared.
The whole thing squared, right? F of theta squared, right? And what's out front? Yeah, because that's the area of a sector when you get, it's d theta, sorry, d theta right here. Okay, so you have, there's something floating out front. You have to be careful about the same thing we talked about in regular calculus this morning. What is up in this case? So if you're doing that region right there, so you're going from like 0 degrees all the way around, correct? Theoretically, it's that region is all the way around. Do you agree? Right? So the challenge is when you're going all the way around, is the same function always the one that's on the top, so to speak? No. For a lot of it, what do you have here? You have a circle, right? Well, the circle is where? That you're looking at from here to where? I'm doing terrible straight lines right here. So I think what they're doing, oh man, I did straight lines so well earlier today.
It's just hard to draw.
Like this. You see this right there? Mm-hmm. So what they're doing is, what's this area right there? What is that area? Well, what's the radius of that circle? So it's going to be pi r squared times whatever percentage of that circle it is, right?
Yeah.
So how do you go by, what do you need to find? What are you going to need to find? Oh, they even tell you, right?
Yeah.
Does it even tell you that? Pi over 6 and 5 pi over 6, right? So how much of the circle is from here to here? Just asking, like from there to there. How much is it from there to there? 4 pi over 6, right? So what is that? 2 pi over 3. Do you agree? From there to there? So what is it from here all the way around like this? How much is that? It's 2 pi over 3. So how much is left? It's 2 pi to go all the way around the circle. 2 pi, and it's
4 pi over 3.
4 pi over 3. Are you okay with this, everybody?
Yeah.
So how much, I'm just asking you, I'm doing this so you can remember basic trig, and also, so how much of the circle, sorry, excuse me. You don't need this one. How much of the circle is right there in yellow? What percentage of the circle is that?
4 pi over 2.
2/3 of the circle, right? So that red region right there is 2/3 of the region, the whole thing. Right? So it's this times what? 2/3, right? So what is that? That's 9 pi times 2/3, which is what? 6 pi. So this right here is 6 pi, right? The rest is not a perfect arc though, right? What do you have to do for that integral? The integral from pi over 6 to what?
5 pi.
They even tell you that. Isn't that really nice? Of what's the outer function?
4 minus 2 sine.
2 sine theta, what?
Squared.
D theta. Now do they want to find the area of S, right? Mm-hmm. And my guess is they just have 6 pi plus this and then an answer.
Yeah.
Because it's a what kind of question? This is a calculator question, correct?
Yeah.
Do you get any points, any glory by doing any part of this by hand? No. Is this, I have a question, it's tempting, is that something you theoretically, if forced to or required to, could you do that integral by hand? Have you integrated sine squared before?